Okay, good day, guys. Today we are going to be determining the support reaction for this beam, which is hingely supported at point A and a roller support at point E. We can see that from the diagram, the beam is carrying a 2 kilonewton point load, a 5 kilonewton point load, and a uniformly distributed load of 4 kilonewton per meter towards support E. So let's familiarize ourselves with some basics. We can see that clockwise movement. First of all, let's define moment. We talk about moment as the product of force multiplied by the perpendicular distance from the line of action of the force to the point of interest. That's moment. And we can see that, okay, clockwise movement is being taken as positive. That is to say, for example, now we can see this 2 kilonewton here is trying to create a clockwise moment about point A. So we term it as positive, while an anti-clockwise moment is termed as negative. So we already know that at point A and point E, there will be no moment, there will be zero moment. So the summation of moment about that point will be equal to 0. So let's start summing them. We can see that we have 2 kilonewton acting at a distance of 1 meter from point A. So we say 2 times 1. We can see 5 kilonewton acting at a distance of 2 meters away from from the support A. We say 5 times 2. All of them are going to be positive because they are creating a clockwise moment about this point, about point A. So we can also see a 4 kilonewton meter uniformly distributed load. So we multiply this 4 kilonewton per meter times 1 to get the total load of that distribution over there. So we are going to say 4 kilonewton per meter times 1, which is 4. So all this load will act at the center of gravity, which is 3.5 meter away from support A. So it's also positive because it's creating a clockwise moment about this point. Then we also look at the last reaction, which is at support E, creating an anti-clockwise moment about point A. So we term it as negative. So equating it and solving for RE, we see that our RE, which is the support reaction, we see that our RE, which is the support reaction at E, is equal to 6.5 kilonewton. And also taking the summation of moment about point E, equating it to 0, we see that this 0.5 distance, at a 0.5 distance away from point E, we see that there is a 4 kilonewton acting, so which is acting anti-clockwise, which is creating a negative moment. We see that, okay, we have 5 kilonewton creating a negative moment also at a distance of 2 meters away from point E. So we see it's 0.5 times 4 minus 5 times 2, because why there are negative, they are creating negative moment. We also see that we have 2 kilonewton at a distance of 3 meters away from point E, causing a negative moment. And lastly, we see RA creating a positive moment about point E, because this reaction here tends to create a positive moment about this point. So we term it as positive, and we equate everything to 0. So solving for RA also, we see that RA is equal to 4.5 kilonewton. So now for we to check our work, we are going to take the summation of vertical forces according to the equilibrium equation. We are going to see that we have first of all, we have 4.5 kilonewton acting upward, and we have 2 kilonewton acting downward, which is negative. We attach a positive sign to all those forces acting upward and negative sign to all those acting downward. So we see minus 2, minus 5, minus 4, plus 6.5. Everything, when you sum up everything, is equal to 0. So guys, these are just the vertical reactions. These are just the vertical reactions. So effect it These are the vertical reactions. So for the horizontal reaction at subpoint A, for the horizontal reaction at subpoint A, x, will be equal to 0 because we don't have any horizontal force acting on the beam. You can see the diagram of the beam. There is no horizontal force acting, and if you should check, there will be no horizontal reaction at subpoint E. Why? Because point E is a roller support. It tends to rotate. When you apply a horizontal force to it, it will rotate. So there is no reaction. There is no reaction that want to counteract the rotation. So there will be no reaction at point E. Okay guys, if you found this video helpful, like, share, and also don't forget to subscribe so you'll be the first person to watch my next video related to this one. And also my WhatsApp number is there on the description below. Message me for a problem or analysis like this.